Hi everybody, this video is a summary of the 2025 measurement project, and in this project we looked around how to apply measurement concepts to building a whare or a house. The project started off by giving you this marking schedule, and I'll just run through the achieved criteria so you know exactly what you need to do at a minimum. But part of it is you're required to communicate some of your findings in a sentence. So you can't just like dump the numbers on your page. You need to actually explain what some of the numbers mean. Obviously, measurement is really important in relation to units. So displaying and showing your units consistently throughout your project is essential for measurement. If you can't do that, we can't say you know measurement skills confidently. Then finally, we've got a list of measurement skills here that we learnt in class during the 2025 year, noting this list slightly changes from year to year. But there was, how many there? There were 7 skills there that you learnt about, and if you were able to show us 4 of these skills at any point in the project, you were able to pass. In addition to that, the project also included a formula sheet for the formulas that you might need it. You can see we've got a whole bunch of area ones. We've got area of a circle there, we've got the circumference of a circle, and we've got the volume over there. So let's get into the background information of the project. So this project was all about developing and building your own whare, your own house. And we've got the section here. So it says a square section is 25 by 25 meters. So we can see we've got the square black rectangle or the black square floating around over here. And it's been purchased to build a whare, build a house. The house will comprise of the following. We can see we've got the main blue house. It's a bit of a composite shape, a few rectangles smushed together to make that main house. We've got a green driveway, and this is a fairly typical driveway shape. We've then got the yellow patio down the back. We've got a concrete square letterbox that's up the front of the house over here by the driveway. And then finally we've got 2 gardens. We've got a triangular garden over here, the orange one, and then we've got another triangular garden, the grey one out the front. They've also given you a few bits of information. GD was the garage door, that's over here. That had a width of 1.5 meters, and the front door out here, that had a width of 1 meter. And you can see a whole bunch of other measurements everywhere, and all of the measurements were enough to do any calculation that you might need to do. So we're going to look straight into task A. So task A was all about the perimeter of this shape. So reading through the question, the section will be enclosed by a fence, and most houses are typically enclosed by a fence, which will follow the boundary. However, it will exclude the driveway. So this driveway part down the bottom here, the cars need to get in and out. You can kind of see it down there. So we can't fence up that. That would be a weird thing to put a fence over. The fencing company has quoted us $175 per meter. And in this task, we've been asked to calculate the perimeter of the section excluding the driveway. That's the first part. We've then got 2 other parts which we'll get to soon. So the perimeter of the fence excluding the driveway, it's really going to be the top shape here. That's going to be, 25 up there. 25 down the left, 25 down the right, and then we've got some annoyances down here and here. So we'll need to figure that out. So the perimeter is going to be 1 plus 2 plus 3, and then we'll call it plus 4 for being extra bits. So that's my general approach that I'm going to take here. So my perimeter, or the way I'd present my working, my perimeter is going to be equal to 1 plus 2 plus 3 plus 4. I know the amounts for 1, 2, and 3 because the section is 25 meters by 25. So that means that's got to be 25, that's 25, and that's 25. So I've got 3 25s I need to add together. So the beginning of my maths, so number 1 or side 1 was 25 meters, number 2 was 25 meters, and number 3 was 25 meters as well. The trick to this question was finding out the bottom length or the remaining length kind of on either side of the driveway. And the way I approached this was I know my total width is 25 meters, and I know the width of my driveway. It's been given to me in the question at 7.5 meters. So the remainder of 4 is going to be the 25 meter width minus the 7.5 meter driveway. So what I'm going to do is that they're combined is the width of number 4. So I'm going to put that in as part of my maths. So I'm going to add on the 25, which related to the total bottom of my section, and then I'm going to take away the 7.5 meter for the driveway because I don't need that fencing. And I'm going to do my math step by step, but the 4 25s add up to 100. So it's going to become 100 minus 7.5, and doing that final one, that was 92 92.5 meters. So we're now on to calculating the cost of the total fence, and that's when the information and the context of the question up the top comes into handy. We know for every meter of fencing we need to make, it's going to cost us $175. So our cost is going to be the meters we require times the cost per meter. So I'm applying a rate here, cost per meter. So we figured out we needed 92.5 meters, and it was a cost of $175 per meter. So I'm going to put a dollar sign there because I need my units. I'm not going to mentally do this, and I would encourage you not to either. Let's do this in our calculator. And when I did that, I got $16,187.50. And we're now on to the last question, where we've been asked to communicate your final answer in a sentence with context. So the first thing I want to mention is, for these wordy questions, it's so important that you know how to communicate what your numbers actually mean. So important that you won't pass without them. My advice for you is the word it should never be used in this type of response. So we can't just say it costs $16,000 or whatever. We've got to be really specific. Don't use the word it. So when I did my sentence, I'll write my sentence down for us all. So the cost of the fencing for the section is, and then I'm going to write down my number, $16,187.50. So important. So when I say with context, I refer to the exact thing you've calculated. It's the cost of the fencing for the section that we're trying to build and develop our new whare on. Just want to go back to the marking schedule to show you what you would have done if you were able to complete that first section. So the first thing is you definitely communicated an answer in context. That was the bottom response. You've included some units here already, probably enough to get achieved. We did 92.5 meters, and we did $16,000. So we've included units enough, and we've done a perimeter calculation over here. And then sneakily what happened is, by applying the $175 measurement rate, we've also done this rate number down here. So we've actually done quite a bit of what we need to do to pass now. So you now really are looking to only pick on 2 of these skills over here in the middle, and the remaining 2 sections to guarantee and shore up your pass. The difficulty some students had was, if you didn't get this perimeter part right, it did mean you had to get some of the harder area skills to ensure your pass. Still obviously very doable, but setting yourself up for success from the first question was really, really important for this one. We're now on to part B, and part B all related to the grass of the section. So I remember when I built my house in Helensville, which was what this is kind of based off, I had the house, I had the gardens, and the rest of it I just planted with grass, and I had to know the kind of the measurements and the dimensions of the area of the grass to know how much kind of to order. So that's what that's based off. So for the following section, the council requires at least 330 meters squared of the section to be grassed. So based on the council rules, this grassed area has to be more than 330 square meters. If it's not, then we're not going to meet the council requirements, and they probably won't approve your house to be built in the first place. So we're going to move on to the first part, calculate the total area of the section. So the total area of the section is the 25 by 25. It's the area of the whole square. So our area of a square area is always equal to base times height, and I know the base is 25 and the height is 25. And when I put that into my calculator, I get an area of 625 meters squared. Now I need to calculate the area of the 6 parts. So I'm going to calculate each area separately. I'm just circling them all. So I need to calculate all 6 of these. And I'm guessing the idea is, once we've calculated all of these, we can take them all away to find all the remaining area. So let's start off with, what I'm going to do is, just to highlight it, I'm going to draw my shapes here. So this here was the first triangle, and it was 6 by 6. So the area of a triangle is always equal to 1/2 of base times height. In this case, that's going to be 1/2 times the base of 6, and then it's going to be times the height of 6. And then when you put that into your calculator, which I encourage you to do, we're going to get 18. And because we're dealing with area, we mustn't forget our meters squared formula, or meter squared units. So I've then moved on to the patio, which was 10 meters by 5 meters. And I'm going to write down my formula. So the area of a patio was equal to base times height, which in this case is 10 times 5, which was 50 meters squared. Move on to the little letter box. I'm just going to draw that over here. So there it is. That's down there. This here was a square, and it was 0.8 by 0.8. And again, we know the area of that is equal to base times height, similar to the section and the patio. That's 0.8 times by 0.8. And when I do that, I get 0.64 meters squared. So I've done 3. So I've done the garden up here. I've done the patio here. I've done the letterbox down there. Let's move on to the triangle up down the front of the house, just picking on all the easy ones first. So there's my sketch. I can see it has a height of 3.5, and I can see it had a base of 7. So our area here, so area is equal to, I won't go across the page, let's go down the page a bit more, 1/2 of base times height. So again, notice every single time I'm doing a calculation, I'm writing down the formula. That's an important part of that working. So in this case, that's going to be 1/2 times by 7 times by 3.5. And again, this is going to be really messy. We've got fractions, we've got decimals. I encourage you to use your calculator to help you out with that. And when I do that, I get 12.25 meters squared. Now onto that trapezium. So I'm going to sketch my trapezium. So I've got a height of 8 meters, it's told me. So height of 8 meters. The top of the shape is 4.5 and the bottom is 7.5. Just noting, I've tried to trick you by giving you these slanted sides of 8.2 meters. Remember, the slanted slide you don't need as part of your calculation for a trapezium. So I'm going to do that here. So down the bottom there, so my area formula is A plus B. So this is in the formula sheet. A plus B over 2. That's basically the average of the top and the bottom. And we're going to times it by the height. And from that, I can now put my numbers in. So I've got 4.5 plus 7.5, or written 7.2, 7.5 over 2. And then I'm timesing that by the height of 8. And then when I did that, I got a total area of 48 meters squared. I'm going to move on to the messy composite shape over here, using the white pen just to highlight things. So that the tricky part of this question was figuring out the dimensions of each composite shape. So I think the logical thing to do here would have been to chop my shape here. That way I've got a rectangle up the top here. And then again down the bottom, chop the bottom up to have a smaller rectangle down there. But to do both of those, you needed the base and the height of each of these 3 shapes. So let's start off with the bottom one. That one was pretty crazy to find. We already knew it was 3 up here. And the driveway width told us that there was 4.5. So that one there was nice to see. The top shape, we've already given the 5.5 up the top there, so we know that's 5.5. And the issue was finding the height of the shape. And if we go across over here to the patio, you were given that height. So that height there is actually 5. It was this middle part that caused a whole bunch of problems for a lot of us. So we need to find the height going from the top rectangle down to the bottom. And the way we needed to do that was, if you can see, the total height there was 12. And we know that this section over here, which is this section over here, was 5. So if we go 12 minus 5, that must be the leftover there, which is going to be 7, isn't it? So that there was 7. And the same with the bottom. The bottom wasn't given to us either. We know this bit here was 11, and we know this bit here was 4.5. So combining those, we knew that the bottom of this rectangle here was going to be 15.5. So like that, I can then find the area. Let's just call this one the house instead of drawing a diagram on it. So the area of the house is going to be the area of the 3 rectangles added together. And each of the rectangles has this base times height formula, doesn't it? So let's start off with the bottom one there. So that would have been 3 times 4.5. So 3 times 4.5. We're going to add on the big one, which was 7 times 15.5. So 7 times 15.5. And then we're going to add on the top rectangle, which was 5 times 5.5. And all of those combined, because a composite shape is a composition of a few smaller shapes. And when I did that, I got 149.5 meters squared. So we're now onto the next part, and this part here asks us to find the total area of the grass. So I've hidden the diagram, but if you remember, all of these numbers were from the previous question, the separate parts of the whare, and all I've done here is I've added up the total to make sure I know the area of the whare. So the area of the grass is going to be the leftover area. So we've got total area of grass is going to be equal to the area of the section, which we had from the previous question. And just noting, I should write that down, that was 625, that number. And we're going to minus away the 6 parts of the house. And then we've got the total of those 6 parts up the top there. So this question was actually quite a nice one. It was 625 minus 278.39. And by doing this, we're finding the area of the composite shape, in this case, the composite shape being the grass floating around it. And when I did that maths, I got 346.61 meters squared. We're now onto the last part of task B, and it says clearly in a sentence, with context, state whether the current plans satisfy the council requirements. So remember, the council requirements were for the area of the grass to be 330 meters squared or more. We found out the area of the grass is 346.61 square meters. That is larger than 330, so it's at least 330, which means the grass we've got will meet and satisfy the council requirements. So let's put that in a sentence. We're going to start by stating the total area of the grass. So the total area of the grass, is, or I've written in, is 346.61 meters squared, which is greater than 330 meters squared. The council's requirements are satisfied. The council's requirements are satisfied. So if you can put a sentence like that, that certainly would be enough to kind of lock in that mark. Now to the final part, task C. And task C is basically, we'll call it the excellence part. It's a chance to show more of the achieved skills, but it's really what we're looking for the excellence thing. And it's all about this idea of construction. And in maths, construction is where you've kind of got to, maybe draw a little bit extra onto the diagram. So you've constructed that in your mind, and then you go ahead and complete the maths in relation to what you constructed. So let's break down the question before we look into this. So the owners of the section wants to add a footpath, so a path and a foyer to help them navigate around the whare, around the house. The first thing is they want a path that connects the garage door. So remember, the garage door is over here with the patio, which is over here. So they want some kind of path connecting these two things. And then the second one is they've got a welcoming foyer, which is in front of the front door. So the front door is here, and it goes along the edge of the house this way and the garden. And you can kind of see that would make a trapezium this way if you made that shape. So what we're going to do is we're going to construct these two things here. It goes on to say that the path and foyer is going to be made out of concrete, but it's going to have a depth of 15 centimeters, which, as a note, because everything else is in meters, is 0.15 meters. So maybe convert that here. We've been told the cost of the concrete, 250 meters cubed. And our job is to go in and draw these new diagrams. And of note, particularly for that first path, it does say the path must have a width of at least 1.5 meters at all times. So we can't have a skinny path. It can be a wider path, but it's got to be at least 1.5. So let's go down to the actual question. So the first question was calculate the volume of the concrete and the cost of the path needed to connect the garage door and the patio, and this is where it needed to have that width of 1.5 meters. So there's a few different things that we could have done here. The first thing I probably would have done is you could have done like a circular path like that, but that seems a bit weird because you waste a lot of this garden space in the middle, so you kind of ruin the flow of your garden. So what I probably would simply do is from the edge of the patio this way here, all the way down to the bottom of the garage door, I would probably just put a rectangular prism floating this way here. So that would be the path. And obviously that path would have the depth of 15 centimeters, and you can kind of see a cuboid turning up there. So that's what my path would look like. And I think that'll be a really simple way to do that. I wanted to note at this point here, whichever path you designed and picked, as long as you did the calculations correct, you would have got full marks for this one. So the tricky part of this is now coming up with the dimensions. So if I'm calculating the area of the volume, and this is a cuboid, isn't it? So the volume of a cuboid, I misspelled volume. Volume of cuboid is equal to base times height times length. So it's basically the three dimensions. So I guess the first thing to note is I know how wide the path is. That has to be 1.5 meters, doesn't it? So that one's nice and easy to figure out. I know how deep the path is. That was 0.15 meters. So I've got two of my dimensions. I now just need to figure out this long dimension, how long that's going to be. And I know, I kind of see hidden underneath here, I know this part of it was 5 meters. We've got another 5 meters over here, so I've just got to figure out how big that door is there. And this was actually given to us in the text of the very first question. We were told that the door had a width of 1.5 meters. So just like that, I know my total length of the path is going to be 11.5 meters. So putting that into my calculation, the base of my shape was 1.5 meters. Then it was times by 11.5 meters, and it was times by 0.15 meters. And when you put all of that into your calculator, which I encourage you to do, you're going to get a volume of 2.5875 meters cubed. So we've done the first part of the question is we found the volume. We now need to find the cost of it. So the cost will be the volume times the $250 per meter cubed. Again, that was given to us in the question. So the cost in this case is going to be the volume in meters cubed times by $250. So it's going to be 2.5875. We're timesing that by 250. So in this case, the cost of adding on this extra path is going to be $646.88. This one here I needed to round, and because it's money, 2DP would be the appropriate rounding in this case. So we're now into the next excellence part. That's calculating the foyer. And remember the front foyer, it was connecting the door. So that's kind of the front house. It went down the side of the house is what the question said. And then it also said it went down the side of the garden. And if you connect that, you'd probably just make a straight line here. So I suppose in theory you could have done something different. Like you might have created like a footpath all the way down here, and then maybe connected all this area. Whatever it might have been. But I think here the easiest solution is to kind of create this trapezium sitting in there. And again, it's going to be a three-dimensional shape because it's going to have that depth of 15 centimeters. So this shape here is not going to be as easy as the trapezium because that was just base times height times length. This time around, we're going to use the volume of a prism formula. So if you remember, the volume of a prism is equal to we'll call it AOF, the area of the face, times by the depth. We know the depth of the shape. That's already 0.15, isn't it? But the area of the face we don't know at this stage here. And that's going to be the area of the trapezium that we've drawn here. So let's start off by doing that. So area of face, and because it's a trapezium, it's going to be A plus B, which is the top and bottom, the parallel lines of the trapezium, divided by 2 times by height. So the top of the shape is along here, and this one's a bit annoying to see. It's not particularly obvious, but the entire length this way here is 11. This bit over here is 7, so that remaining bit there must be the 4. So that's 11 minus 7. So that's going to be 4. So let's put a big 4 on the top there. The bottom we've been given 5.5. So that's going to be easy. So we're going to have 4 plus 5.5, and all of that's going to be divided by 2. We now need to times that by the height, and that's given to us as well, 3 meters. So plugging that into my calculator, I'm getting an area 14.25 meters squared. I can now kick in and put that into my volume part. So the volume, as we said earlier, so the volume is going to be the area of the face, which is 14.25, and we're going to multiply that by the depth, 0.15. And then when I do that, I get a volume of 2.1375 meters cubed. Like we did in the previous question, now that I've got the volume, I'm going to times it by my cost, $250 per meters cubed, and that'll give me the cost of this new foyer. So the cost is going to be equal to 2.1375, and I'm going to multiply that by $250. And that there is going to be equal to 534.38. And that was rounded to 2dp again because that's a measurement of dollars, which goes to cents, which is hundredths. So we're now writing up. So every question we've been asked to communicate in context what that actually means. So the previous numbers for the total cost that we're trying to add together. So we had the total cost of the path, which I'm just going to jot them down here. That's 646.88, and then I had to add on the total cost of the foyer, which was 534.38. When I add them together, I get 1181.26. So that is my total cost. So I'm now just going to explain what that number actually means for the context of the scenario. So we're going to write, so the total cost of adding the path and foyer is 1,181.26. So that wraps up that question. We've now got our final question. We mustn't forget about the council requirements we talked about in part B. So we were told 330 square meters was the amount of grass that we need. We've now gone ahead, we've added in more concrete, so which means we're taking away some of the grass. So we now got to check, are we still complying with that requirement? And I've got some numbers down here from before. So from task 2, we found out we had a grass area of 346.61. We've now added in a foyer, which we calculated in the previous question to have an area, or the face had an area of 14.25. We never actually found the area of the face of that because we went straight to the volume question. So if I did that area of path, so let's write path area, that would have been just base times height. So that would have been 11.5 times by 1.5. And that area, when I do that calculation, is, just get my calculator out, 17.25 meters squared. So my total grass area was this amount. I'm now going to take away this amount because I've now added in the foyer, and then I need to take away this amount here. And that's going to give me the new grass area. Let's jot that down. So we're going to write the new grass area is going to be equal to the original 346.61 minus the 14.25, which is the foyer area, and then minus 17.25, which was the path area. And then when I do that, I'm left with an area, I've written the one first, but we're left with an area of 315.11 meters squared. Now this number is bad news for the council requirement that we need to comply with. It's now less than that. So we've got too much concrete. We haven't got enough grass, so we're not able to meet this requirement. So we're now going to explain that for our final answer of this project. So the new grass area, after the foyer and path were added is 315.11 meters squared, which is less than 330 meters squared. We now, mind my bad spelling, we now no longer meet the council's 330 meters squared grass requirement. So that means, if this was the real world, we would have to go back, we'd have to reconsider our plan, and then maybe resubmit that with the council to make sure we can show them we're meeting the rules that they are asking us to comply with. So that wraps up the Achieve video from last year's Year 9 measurement project, the 2025 one. Hopefully you found it useful. Remember, every project, it changes from year to year. So this one didn't have any circles, so a future one might have circles. This one had perimeter, area, volume. The next one, maybe there's no area in the next one, or maybe there's no volume, maybe there's no perimeter. But it should be combinations of perimeter, area, volume with varying shapes, which may or may not include curved edges or curved circles as part of your response.